The Planck constant is an extremely important term and concept for our modern day understanding of physics, especially in the quantum realm. So, to understand Planck constant fully, let's start with this paradox. So in this paradox, let's look at this clock. Let's say I want to go from 6 a.m. to 7 a.m. using half measures. This means that firstly I go to 6:30 a.m., then I go to 6:45 a.m., then I go to 6:52 and 30 seconds, on and on. Doing this, will I ever reach 7 a.m.? Well, there are a lot of flaws to this paradox, but one solution to it is the Planck constant. We're assuming here that time or length can be infinitely split down, when this is simply not the case. Let's get back to this later. Firstly, let's talk about light. What is light and why does it glow the color that it does when something is heated? Well, these were the questions that scientists were asking in the late 19th century and early 20th century. So in order to find the answer to this, scientists mapped the wavelength of light against the intensity of the light. Now this was done in something called black body radiation. Now you can see that this box is black outside and inside. So what this means is that, imagine this was a perfect black. It means that all the electromagnetic radiation that would go inside it would be absorbed by this black. These are things like radio waves, infrared, and of course visible light. So what this means is that this black box will keep absorbing these electromagnetic waves until the temperature of the box becomes the same as its surroundings. Now for the black body to keep its temperature the same as its surroundings, it releases energy to keep this temperature same as its surroundings, and this energy is released through electromagnetic waves. So what scientists do is that they take the wavelength of this electromagnetic waves and also the intensity of it to map this black body spectrum. So as you can see, as the curves have a higher temperature, their peaks of their intensity are at a lower wavelength or higher frequency. So these curves were actually found with careful experimentation by seeing in different wavelengths of electromagnetic rays against their intensities at different temperatures. But the problem was to find a solution in classical physics to map this curve. So, to try to solve this using classical physics, Sir James Jeans and Lord Rayleigh came up with the equipartition theorem. So this theorem took into account every possible frequency of a particle's vibration, every possible amplitude, and every possible direction it could be vibrating, and it averaged this using the equipartition theorem. So after equipartitioning it, this curve was formed. Okay, so that does not really look like the black body radiation curve, does it? So why was this the case? This was what all the scientists were asking back then, and they named it the ultraviolet catastrophe. So this means that something is wrong with classical physics. The reason this happened was because when equipartitioning, Rayleigh and Jeans took into account every tiniest small vibration. Because they could go infinitely down, there would be infinitely small vibrations. So adding all these infinitely small vibrations would add up to an infinite amount of energy. Hence why the curve goes up to infinity. So the person who actually solved this catastrophe was Max Carl Ernst Ludwig Planck. So what Planck did back then was regarded as crazy, but it worked. What he did was he added a constant, a hypothetical constant, to the frequency of the light, and made that every possible energy is a multiple of this constant times frequency. So what this is doing is that this is breaking energy into discrete amounts, into quanta. This is because now there aren't an infinite amount of small energy. There is a smallest energy. This frequency times the Planck constant is the smallest amount of energy, and every energy that comes after that is a multiple of it. So now there wouldn't be an infinite amount of smallest energies, and so the curve wouldn't go to infinity. So when equipartitioning it with this Planck's law, lo and behold, the curve matched the black body radiation spectrum. So like many other concepts in physics, Einstein came along and told us what this actually meant. So he came up with the photon. He said that the photon is a small packet of energy, a small packet of frequency, and so one photon is the HF. These photons are HF. They're a small packet of light, a small packet of waves, and a discrete amount of energy. So all the light we see around us are multiples of these photons. So the discovery of the Planck constant led to this equation, E equals to HF. So this means that the energy of any photon depends on its frequency times the Planck constant. Now these would solve the clock paradox because it would mean the clock is going in discrete amounts, meaning that it can never be infinitely small, and so it will reach 7 a.m.